Hello students, today we will solve the problem based on the concept of electric potential. We know that electric potential due to the point charge is given by the expression V is equal to 1 divided by 4 pi epsilon naught Q divided by R. This is the expression for the electric potential due to the point charge, where Q is the charge, R is the distance at which the charge is placed. The 1 by 4 pi epsilon is a constant, and the value of 1 by 4 pi epsilon naught should be remembered, that is 9 into 10 to the power 9, which we have studied in the first chapter. The value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So students, the first problem we have here that is 2 point charges plus 8 microcoulomb and minus 16 microcoulomb are separated by 0.6 meter distance. Find the points on the line joining the charges at which the potential is 0. To solve any problems in physics, first of all we have to understand the problems clearly. So to understand the problem, read the problem clearly so that we can understand what we have to solve here. So I will read once again here. There are 2 point charges plus 8 microcoulomb and minus 16 microcoulomb are separated by 0.6 meter distance. Find the points on the line joining the charges at which the potential is 0. We have to find the potential at the points. Yes, find the points on the line joining. On the line joining we have to find the 2 points. So here there are 2 charges, 8 microcoulomb and minus 16 microcoulomb. They are separated by the distance 0.6 meter. 0.6 meter. This is the distance between them. What they are asked, find the points on the line joining. On this line joining we have to find the 2 points where the total electric potential is 0. I will find the points, say that at this point, say P, between these 2 points, between these 2 points A and B, this is the first point, and the second point I will find here, that is outside the 2 charges. The point lies inside the 2 charges and the point lies outside the charges. These are the 2 points where we have to find the electric potential at a distance, right? So let's solve this problem now. As I said that we have to find the points or the positions on the line joining the 2 charges, right? We have to find the points on the line joining. We have to find the points on this line joining the 2 charges. This is the line which joins the 2 charges, and on this line we have to find the position or the point. So there are 2 points. The point lies between these 2 points. The point lies outside the points. These are the 2 points where we have to find the electric potential. Okay, so let's see. So first we will find the what they have given. There are 2 charges given, that is Q1 is equal to plus 8 microcoulomb. Micro means it is 10 to the power minus 6 coulomb. Q2 is given minus 16 microcoulomb. So it is 16 into 10 to the power minus 6 coulomb. and they are given the distance that we call r, it is 0.6 meter. Okay. So let P be a point between A and B where, or let P be a point between the A and B at a distance x, at a distance x from A where total electric potential is 0. Right. Let P be a point between A and B at a distance x from the A where total electric potential is 0. I will draw here. These are the 2 points A and B. As I said, let P be a point, let P be a point at a distance x from A, right. This total distance they have given, how much it is? It is 0.6 meter. So if it is x, then the remaining distance BP must be, it is 0.6 minus of x, right. So here we have 8 microcoulomb and here we have minus 16 microcoulomb. Okay. So now total electric potential at P must be equal to what? 0. So we will find the potential at A plus potential at B must be equal to V. So VA plus of VB equal to what? 0. V is the total electric potential, it must be equal to what? 0. So VA plus VB must be equal to what? 0, right, as the problem says. Find the points on the line joining the charges at which the potential is 0. So total potential is 0 now. So let VA is nothing but what? 1 by 4 pi epsilon naught q1 divided by, what is the distance of this? That is x, right. And VB same, it is 1 by 4 pi epsilon naught q2 divided by this distance, that is BP, it is 0.6 minus of x, right. So we will substitute the values VA plus of VB. So it is 1 by 4 pi epsilon naught q1. What is q1 here? It is 8 microcoulomb, that is 8 into 10 to the power minus 6 divided by x. Here we have minus 16 microcoulomb. So according to this VA plus of VB, VB I can write, it is minus of 1 by 4 pi epsilon naught 16 into 10 to the power minus 6 divided by 0.6 minus of x, which is equal to 0, right. Electric potential due to the negative charge is negative, that is why this plus becomes what? Minus of 16 microcoulomb they have given. So this minus comes here. Okay. So this 1 by 4 pi epsilon naught 8 into 10 to the power minus 6 divided by x, which is equal to 1 by 4 pi epsilon naught 16 into 10 to the power minus 6 0.6 minus of x. Okay. So this get cancelled, 10 to the power minus 6, 10 to the power minus 6 get cancelled. We have what? 8 by x is equal to 16 divided by 0.6 minus of x, right. So cross multiplication, 8 into 0.6 minus of x, which is equal to 16x. So 8 into 0.6, it is 4.8 minus of 8x, which is equal to 16x. So minus 8x becomes plus 8x. So plus 8x plus 16x, which is equal to 24x. So it is 24x is equal to 4.8. Therefore x is equal to 0.2 meter. X is equal to 0.2 meter. This is what the distance between the points we get here, right. Similarly, we have to find another point, that is point P lies outside the charges. Let P be a point, let P be a point outside the two charges, outside the two charges. Say here I will draw the points. This is A, this is B, this is 0.6 meter, they have already given. So this is the point P, which is at a distance x from A, right. So we have 8 microcoulomb here and it is minus 16 microcoulomb here. So earlier what we have seen, the point P lies between the charges, lies between the charge. Now this point P is outside the two charges. So point P lies at a distance x from A. Then this BP becomes what? 0.6 plus of x, 0.6 plus of A. Therefore I will use the same expression now, VA plus of VB here. Again VA is same, that is 1 by 4 pi epsilon naught Q1 by x, and VB is equal to 1 by 4 pi epsilon naught Q2 divided by this distance is now 0.6 plus of x, 0.6 plus of x. Therefore VA plus VB equal to 0. Substitute the values. Same I can write 1 by 4 pi epsilon naught 8 into 10 to the power minus 6 divided by x, minus of 1 by 4 pi epsilon naught 16 into 10 to the power minus 6 divided by 0.6 plus of x, which is equal to 0. Why negative sign? That I already have said that electric potential due to the negative charge is always negative. So it is 1 by 4 pi epsilon naught 8 into 10 to the power minus 6 divided by x, which is equal to 1 by 4 pi epsilon naught 16 into 10 to the power minus 6 divided by 0.6 plus of x. So this 1 by 4 pi epsilon naught, this 1 by 4 pi epsilon naught get cancelled, 10 to the power minus 6, 10 to the power minus 6 get cancelled. What remains here? 8 by x, which is equal to 16 divided by 0.6 plus of x. So it is 8 into 0.6 plus of x, which is equal to 16x. So it is 4.8 plus of 8x, which is equal to 16x. So 8x gets minus. So 16x minus of 8x is equal to what? 8x, which is equal to 4.8. Therefore x is equal to 4.8 divided by 8 is 0.6 meter. These are the 2 points. The distance x is equal to 0.2 meter, the electric potential is 0, and at a distance x from 0.6 meter the electric potential is 0. These 2 points the both these 2 points are lies inside as well as the outside. The first point lies inside the 2 charges and the second point lies outside the 2 charges. So these questions are asked in the examination for the 5 marks. Okay. So it is the next problem. Point charges 2 nanocoulomb, 4 nanocoulomb and 8 nanocoulomb are placed at the corners of A, B and C respectively of a square of a side 0.2 meter. Calculate the work done in transferring a charge of 2 nanocoulomb from D to the center of the square. This is also very important problem, usually asked in the examination for the 5 marks. So as the problem says that there are charges 2 nanocoulomb, 4 nanocoulomb and 8 nanocoulomb are placed at the corners of A, B and C respectively of a square of ABCD of side 0.2 meter. Calculate the work done in transferring a charge of 2 nanocoulomb from D to the center of the square. Right. So look at this board. You can see it is a square. This is point A, point B, C and it is point D. Alright. Point charges 2 nanocoulomb is placed at here, 4 nanocoulomb is placed at here and 8 nanocoulomb is placed at this point. And the side of this square is 0.2 meter. So I will draw here. A square, it is A, B, C and D of side 0.2 meter. Right. Point charges 2 nanocoulomb. So it is 2 nanocoulomb is placed here, 4 nanocoulomb at this point and 8 nanocoulomb at this point. Calculate the work done in transferring a charge of 2 nanocoulomb from D to the center of the square. So center of the square means we have to draw the diagonal. So this is the center of the square. We will call it as O. Alright. So we have to take a charge of 2 nanocoulomb and we have to transfer this charge from D to the point O. Alright. This is what the problem says. 2 nanocoulomb, 4 nanocoulomb and 8 nanocoulombs are placed at the corners of A, B and C respectively of a square ABCD of side 0.2 meter. Calculate the work done in transferring a charge of 2 nanocoulomb from D to the center of the square. There is one charge 2 nanocoulomb and this 2 nanocoulomb has to transfer from the D to the O. So to transfer a charge of 2 nanocoulomb from D to the O, first we have to find the electric potential at point O and at point B. Right? We will find the electric potential at point O. So here we will get the potential O here, and we will find the potential at point D, and the potential difference between O and D is the total potential difference, and using that potential difference we will find the work done. Right? So here from figure, AC which is equal to BD is called diagonal. We call it as the diagonal. Right? And diagonal AC or BD which is always equal to root 2 into side. Please remember, diagonal is always equal to root 2 into side. Alright. So root 2, what is the side here? It is 0.2 meter. Side is what? 0.2 meter. So AC or BD which is equal to what? My root 2 into 0.2 meter. So now from figure we can write the distance AO, because we have to find the potential at O, so this distance must be find out. So this AO, which is equal to BO, which is equal to CO, which is equal to DO, which is exactly half of the diagonal. Half of the, so this distance AO is half of the diagonal. So I can write AC is what? It is 0.2 into root 2 divided by 2. So 0.2 divided by 2, it is nothing but what? 0.1 into root 2. 1 into root 2. Right? So we get this distance AO, BO, CO, right, and DO. So the total potential at O is, I will write it is BO, which is equal to 1 by 4 pi epsilon naught into the bracket AO. So it is Q1 divided by AO, potential at O due to this charge, plus potential at O due to this charge, that is Q2 divided by BO, plus potential at this point due to this charge, that is Q3, that is CO. So we are finding the potential at O. Right? So we can write here VO is equal to 1 by 4 pi epsilon naught. The value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Right? Value of Q1 is nothing but 2 nano coulomb. Nano means it is 10 to the power minus 9. What is AO here? AO is nothing but what? 0.1 into root 2. So it is 0.1 into root 2 plus Q2 is how much here? It is 4 into 10 to the power minus 9 divided by 0.1 into root 2 plus 8 into 10 to the power minus 9 divided by 0.1 into root 2. Okay, so it is VO, which is equal to, see here, 10 to the power minus 9, 10 to the power minus 9, 10 to the power minus 9 is common. So I will take it outside. It is 10 to the power 9, it is 10 to the power minus 9. Okay, what remains inside here? 2 plus 4 plus 8. 2 plus 4 plus 8. So 2 plus 4 is 6, 6 plus 8 is 14. So it is 14 divided by, LCM is common, so 0.1 into root 2. Right? So this 10 to the power 9, this 10 to the power minus 9 get cancelled here. So 9 into 14 divided by 0.1 into root 2, after calculating we will get here, it is 891 volts. 891 volts. Right? So root 2 is nothing but what? So it is 9 into 14 divided by 0.1 into 1.414. So after calculating this, we get what? 891 volts. Similarly, we will find total potential at D. We will find the potential at D. So we will write it as VD, which is equal to 1 by 4 pi epsilon naught Q1 divided by this distance. What is this distance? It is AD. Alright, plus Q2 divided by this distance is BD plus Q3 divided by this distance is CD. Look at here. First we find the potential at O here, then we find the potential at D here. So to find the potential at D, we have to know the distance from A at this point. So the potential at D due to this charge, so that is distance AD. Potential at D due to this charge, so it is distance at BD. Potential at this point due to this charge is a distance CD. So all I have written here Q1 by AD plus Q2 by BD plus Q3 by CD. So it is, we know 9 into 10 to the power 9. Q1 is nothing but what? 2 into 10 to the power minus 9 divided by AD. AD is nothing but what? Side. So it is 0.2 plus Q2. Q2 is how much? 4 into 10 to the power minus 9 divided by BD. BD is nothing but the diagonal, and diagonal distance we have know it is 0.2 into root 2. So it is 0.2 into root 2. Remember, BD is the diagonal, and diagonal we have calculated, it is a root 2 into 0.2 plus CD. CD is 8 into 10 to the power minus 9 divided by CD distance is, that is 0.2. right? Again 9 into 10 to the power 9, 10 to the power minus 9 is common, take it outside. What remains inside? 2 divided by 0.2 plus 4 divided by 0.2 into root 2 plus 8 divided by 0.2. So after calculating all this, we get exactly, that is 577 volts, right? After calculating this, we get what? 577 volts here, right? So T2 divided by 0.2, we can calculate this one, and 8 divided by 0.2 also you can calculate. So 4 by 0.2 into root 2, right? Earlier here we have the same LCM at this point, but here LCM is different. So 2 divided by 0.2, first you have to calculate, then 4 divided by 0.2 into root 2 plus 8 divided by 0.2. After calculating, we get what? VD is equal to 577 volts. Therefore, potential difference between O and VO and VD is V is equal to VO minus of VD. VO is how much? That is 891 minus of 577. We get out approximately 313 volts approximately, right? 313 volts. So what they are asked, calculate the work done in transferring a charge of 2 nanocoulomb from D to the center of the square. So work done in transferring a charge of 2 nanocoulomb from D to O, W is equal to V into Q. V is nothing but what? 313. Q is nothing but what? 2 nanocoulomb. So it is 2 nanocoulomb. So we can calculate, that is 616 into 10 to the power minus 9 joule. This is the work done, right? So it is 626, 2 3 is 6, 2 1 is 2, right, 6 into 10 to the power minus 9 joule. This is the work done in transferring a charge of 2 nanocoulomb from D to O, right? So while this solving the problems, see here, first we have to find the potential at O. We have to find the potential at O, then we have to find the potential at D, then we will take the potential difference between the D and O, that gives the total potential V, then work done W is equal to V into Q. Alright, so this is the problem based on the electric potential.